Okay, so let's look at our day 2. So for day 2, yeah, I need to change here is 2. It's not day 1 anymore. So for day 2, we'll just talk about the divisibility rule. So it's a very important part in the competition. It belongs to the number theory. So actually it's a very important thing. And also remember when you start learning the Math Olympiad in P2 or P3, your teacher will tell you, okay, so how to determine number can exactly divide by 3 or divide by 9. So maybe the teacher will just tell you, so yeah, I just add all the digits up, and if the sum can divide by 3, then all the number can divide by 3. If the sum can exactly divide by 9, so all the number can be exactly divided by 9. Okay, so this is about the divisibility rule. So today I will just show you all the things about the divisibility rule, and sometimes you can come back home and think about how to prove that. So the first thing is about the divisibility rule. Okay, so yeah, we use like that. So we call this one a line here. So we see this means B can exactly divide it by A. So if B can exactly divide by A and C can also exactly divide by B, then we have C can exactly divide by A. And also if B can exactly divide by A and C can exactly divide by A, then we can see B plus C can exactly divide by A. Also B minus C can exactly divide by A. Okay, so for the third one, if we have B can exactly divide by A, that means what? That means if I times a K, a constant value for both A and B, we have KB can exactly divide by KA. So it will be very easy to prove. You just take some numbers inside, you can find out that. So another one, so we have if B times C can exactly divide by A. And also we know A and B, they are co-prime. That means their highest common factor is 1. Then we have C must exactly divide by A. So this is about the divisibility rule. Okay, so also we have another one. So how to determine whether this number can divide it by 3, 4, 5 or something else. Okay, so we have the divisibility table. Right, so for the table, you can find, so sometimes we just need to determine the last few digits. So the first one, the last n digit. Right, so for example, we can find this one. Actually, we are talking about the factor of 10 to the power of n. So for example, if n equals to 1, n equals to 2, and equals to 3. So if a number can exactly divide by 10, so that means this number, the last one digit can divide by 2 and 5. If the one number can exactly divide by 100, that means we need to focus on the last 2 digits. So they can both divide by 4 and 25. And also, if you want to check whether this number can exactly divide by 1000, so it should be 8 and 125. What else? This means if you want to check if one number, the last one digit, can exactly divide by 2 or 5, you just look at the last one digit. If you want to check whether this number can exactly divide by 25 or 4, you just look at the last 2 digits. If can exactly divide by 4 or 25, then can. If you want to check what number can exactly divide by 8 or 125, you just look at the last 3 digits. Okay, so this is the last digit. So also, yeah, we have the most familiar one is the sum of n digits. Okay, so this is about what? This is about the factor of 10 to the power of n minus 1. Like what? Like if I have, so n equals to 1, so it can be divided by 9, right? So we can use 3 and 9. If I want to check a number, if can divide by 3 or 9, you just plus them together. And also, yes, about 2 digits, you can focus on the 11, 99. And if n equals to 3, so it should be 999. And also remember, 99 we can separate to 27 times 37. So these three numbers, we just determine the sum of the digit is okay. Okay? So also, yes, we have another one. So about the difference of n digit. Okay? So this, we just focus on the factor of 10 to the power of n plus 1. So yeah, you can have a try. So if n equals to 1, so it will become 11, 101, and 1001. And be careful, 1001 we can separate to 7 times 11 times 13. So 7, 11, and 13. We can use the same method to separate. Okay? So yeah, how to determine, how to make sure whether we can use this number or not. So I will show you two very easy example. You can prove that. So for example, 25. How can I determine 1, 2, 3, 4, 5? Can exactly divide by 25 or not? So we just look at the last two digits. So you cut it here, it will become 12300 plus 45. So firstly, we know this 12300 can be exactly divided by 25. So we just need to check 45, right? So if 45 can exactly divide by 25, then all the things can divide by 25. Of course, this 45 cannot. So that means 1, 2, 3, 4, 5 cannot exactly divide by 25. Okay, so now let's look at the next one. How about 99? So still use the same one. 1, 2, 3, 4, 5. This one you look at that. So if n equals 2, right? So I need to use the 2-digit cut. I cut like here. Okay, so this one I can separate to 1 times 1, 10,000 plus 23 times 100 plus 45, right? But this one, how can I determine? So we can take out this 1 plus 23 plus 45, then we times, so we plus 9999 times 1 plus 23 times 99. So that means this part must be the multiple of 99. This 123 times 99, also the multiple of 99. So we just need to determine 1 plus 23 plus 45, whether this answer is the multiple of 99. Obviously not. So this one cannot be exactly divided by 99. Okay, so now let's show you another example about 11. Okay, so about 11, so we should use what? We should use 1-digit cut, right? So what is the meaning of 1-digit cut? So 1, 2, 3, 4, 5. We still use this example. So that means you need to, from right to left, in 1 digit, have a cut. 1, 2, 3, 4. And now this is group 1, group 2, group 3, group 4, and group 5. So we need to plus all the even group and plus all the odd groups. So it should become 5 plus 3 plus 1. This is the odd group. And about the even group, which is 4 plus 2, right? 4 plus 2. This is the even group. So we find out the difference of odd group and even group. We do the subtraction. So you can find out this one is 9 minus 6, which is 3. If this result can exactly divide by 11, so that means all the things can exactly divide by 11. Why? So you can use the same method to use the place value principle to separate. It will become 1 times 10,000 plus 2 times 1,000 plus 3 times 100 plus 4 times 10 plus 5 times 1. Then you can separate like 5 minus 4 plus 3 minus 2 plus 1. Then we plus 11 times 4 plus 99 times 3 plus 2 times 1001 and plus 1 times 9999. So all the remaining behind things, this is the multiple of 11. So all the things, we just need to determine the first part. If can exactly divide by 11, so all the things can exactly divide by 11. So we can have a conclusion. So if a question is very hard, so for example, for some composite number, so if I want to ask whether this number can exactly divide by 6, well, so we should know 6 is 2 times 3, so you should determine 2 and determine 3, right? So the order is always we check the last digit, then we check the sum rule, then we check the difference rule. Okay, so you should obey this order to check it one by one. And also, so for some harder question, we have another method. When you look at the practice 3 question, there is one. So you can use this method, the divisibility table, to check one by one. But also, I will show you another method. We can do it very quick. Okay, we can do it very quickly. Okay, so now, also we have another very important thing need to mention. So it's about the special rules. Okay, so it's about a 9. 9 we can use another way. It's about a random cut. Random cutting. So for example, if I have 1, 2, 3, 4, 5, 6, 7, 8, 9 until 2023, 2024. This is a multiple digit number. How can I determine whether this number can exactly divide by 9 or not? So we can use the digit cut. We can check 9. We can random cut like that, right? I cut all the 1 digit, all the 2 digit, and all the 4 digits. So that means 9. We just need to check whether it can be exactly divided by 1 plus 2 plus 3 plus 2024. And then this part, yes, we can use the Gaussian sum. This is actually 1012 times 2025. You just need to check whether this one can exactly divide by 9. So of course it can. So that means this part is the multiple of 9. Okay, so this one we call them, for 9 we can use the random cutting. Okay, we can use the random cutting. So this is all the things about the divisibility rule. So the rule itself is very easy to remember, but actually how to use that in the real questions is a little hard. Okay.